everyone, welcome back to this series of database internal. We already have talked about transaction, atomicity, and consistency. In this video, we will learn about isolation. Isolation is really important topic. Before going ahead with isolation, what exactly is isolation? We will talk about why do we even need isolation. We will take example of transferring money from two accounts to a third account. Let's take this example of Alice, Bob, and John. Alice and Bob is trying to send money to John. So these are the two accounts trying to send money to the same account, John. Basically, if you can see account table over here, there is ID column, balance column, and name, right? Alice and Bob is trying to send money to John, right? Alice is trying to send $50. Bob is trying to send $100. And John's current account balance is $100. So in total, after these two transactions, the successful and the consistent data should be $250, right? Before these two transactions, this is the balance of the account. Let me show you after transaction T1 and T2 how the balance column look like. So basically, Alice is sending $50 to John's account. That's why it is $650 after transaction T1. Bob is sending $100 to John's account. That's why Bob is at $400. And John is receiving $50 plus $100 from Bob's balance. That's why John's balance should be $250, right? Now let's see it in action. If these two transactions, transaction T1 and transaction T2, are happening simultaneously, any transaction starts with begin transaction. So this transaction T1 is Alice sending $50. This transaction T2 is Bob sending $100. Now we will start with begin transaction. Transaction T1 had started earlier, and at this line number 3, we are just declaring sender balance. At line number 5, we are initializing that sender balance. Basically, what is the sender balance right now? So basically, where ID is 1, right? Sender balance of ID 1 is nothing but $700. This sender balance will be $700. It is checking if $700 is greater than or equal to 50. It is greater. It will come inside this if condition. What it will do is where ID equals to 1, it will decrement the balance by $50. Let's do that. So it will be $650. Now, meanwhile, this transaction also started, and it also declared the variable, initialize this variable with balance ID 2. So basically 500. Now 500 is greater than 100. It will update the balance, and it will update the balance of ID 2. Basically, it will decrement $100. So let's decrement this. So it will be basically $400 after decrementing $100. Now both of these will come to this, and they will try to execute this write query, basically this update command. So basically, Alice will try to add $50 to John's account, and Bob will try to add $100 to John's account. And John's current balance is nothing but $100, right? So at the same time, Alice is trying to write $150 over here, and at the same time, Bob is also trying to write $200 over here. Now, one of the data will be lost. So basically, we have seen the final amount should be $250. But in this case, what exactly is happening? Transaction T1 and T2 is happening simultaneously, and one of the value will for sure get overridden. If they are trying to change the value or balance of John's account at the same time, one of the value will get overridden, right? So let's say Alice changed the balance first, $150, and then Bob is trying to change the balance. Then it becomes $200. This is inconsistent state. John's balance should be $250, but it is $200 because they both tried writing at the same time. They both read the balance. John's balance was $100, and they both are trying by adding $50 and $100 respectively at the same time. This is nothing but lost update. So these things are called anomalies. Basically, there are issues when multiple transactions trying to operate at the same time. It might be possible one transaction is a read transaction, one transaction is a write transaction, but because both are happening simultaneously, there might be chances of data inconsistency. There is something called isolation anomalies. The one that we have seen was lost updates. There are basically many anomalies, but we will talk mainly about these 4 anomalies: dirty read, non-repeatable read, phantom read, lost updates. So we will see all the problem happen when multiple transactions are happening at the same time and trying to read and write on the same data, right? Let's understand first, and then we will see how isolation levels help to prevent such inconsistency in the data. The very first thing is dirty read. Dirty read is nothing but one transaction reads uncommitted changes made by another transaction. What do I mean by that is there if there are two transactions, let's say transaction T1 and transaction T2, this transaction writes something into the database. While that write has not yet been committed, transaction T2 read the write made by transaction T1, right? So basically, transaction T2 read something which was not committed by another transaction. This is what the dirty read is. Let's see this with this diagram. So there is transaction T1, there is transaction T2. Let's say we started the transaction and we are committing the transaction. We are saying read value. Let's say we are trying to read this value 200. What we got here was 200, right? Now we are trying to write value. So basically we read X. Now we are trying to write X plus 2. That is 202. So the value that will be written over here is 202. Meanwhile, transaction T2 read this value. And what it read is 202. And this transaction T2 failed at query 3, which is trying to read the same value again. Now transaction T1 will roll back the write that it has done, right? Again, value will become 200 and this whole transaction will be rolled back. But T2 has read a value which was not committed and has been rolled back. This is what dirty read is, right? Let's see this with an example. So example is there are two transactions, transaction T1 and transaction T2. Alice is sending $50 to John and transaction T2 is checking Alice's balance. So basically it will be similar step. We'll start with begin transaction. We will declare a variable called sender balance. We will initialize this variable sender balance where ID is 1. So sender balance will be 700. 700 is greater than $50. We will come inside this if block. What we will do is we'll decrement Alice balance by $50. So Alice balance will be 650. At the same time, this transaction read the value of ID1. So what it read was $650. And when transaction T1 came at this query, something went wrong. This query failed. Once this query failed, this transaction T1 has to roll back. But T2 has read a value which has not yet been committed by transaction T1. But the value is rolled back to 700, which was earlier. Now transaction T1 has been rolled back. It has deducted this balance minus 50 and again rolled back to 700 in balance of Alice account. But what T2 has read was a transaction which has not yet been committed. So this is nothing but dirty read. Next isolation anomaly is nothing but non-repeatable read. A non-repeatable read can be defined as a transaction reads the same data twice and gets the different value because while this transaction was executing, some other transaction modified the data in between. What do I mean by this definition? Let's go and understand by this example. So there are two persons, Bob and Alice. Bob is checking balance twice in the same transaction. In the meantime, Alice is sending $200 to Bob. So basically, initial balance of Alice is $700 and Bob is $500. So Alice will send $200 to Bob, then Bob's balance will be $700 after this transaction, and Alice balance will be $500 after Alice send the money to Bob. Now let's understand this with these two transactional queries. There are two transactions, transaction T1 where Bob is checking his balance, doing some other work and checking balance again. There is transaction T2 where Alice is sending $200 to Bob. Let's understand this. We start with begin transaction. We declare two variables basically, initial balance and final balance. We initialize the initial balance where ID is 2. So initially the balance will be $500 for Bob, right? Then there are some other queries and operations going on. Meanwhile, this transaction took place and what happened is Alice had $700. So Alice initialized the sender balance as 700. 700 is greater than 50 rupees. It will come and deduct that $200 from Alice account where ID is 1. Let's do this. It will be 500 and update the balance of ID2, right? So it will add that $200 to Bob's account and commit the transaction. While this transaction was in progress, transaction T2 made some changes to this table, right? Now Alice has 500 rupees and Bob has 700 rupees. Again, transaction T1 is trying to read from the same ID where ID is 2. It read earlier where ID equals to 2 in the same transaction. Now it is reading again in some other variable, let's say final balance. Now this time transaction T1 will get $700. So earlier, initial balance was $500 and this time it got $700. Basically, if initial balance and final balance is not equal, then it is a non-repeatable read anomaly. So if you see these two select query are exactly same, we are just initializing two different variables. So these two select query is checking balance of the same account ID and also in the same transaction, but getting different values in both of the query. This happened because transaction T2 changed the value of Bob's account balance in between when this transaction T1 was in progress. This is nothing but non-repeatable rate. Next isolation anomaly is phantom read. So what is phantom read? A transaction reads a set of data and then another transaction insert new data into the same set, or you can say deletes a record and causing the first transaction to see different result on subsequent read. What do I mean by that is, let's see this example. Let's say you are querying something like balance is greater than $150. Then you will get multiple rows as a result, right? Now there is another transaction T2 which inserts a new row or deletes a row, might change the data set. Let's see with this example. So here is our account table. We have ID, balance, and name. We have 4 records over here: Alice, Bob, John, and Alex. Let's copy this table and see what record we will get. So this is transaction T1 and this is transaction T2. Transaction T1 is saying select star from account where balance is greater than $150. In that case, record with ID 3 will not be here, right? So let's delete this. Now this query will result something like this. Now in the meantime, this transaction T2 inserts a new record, which is ID 5 and balance is 1000 and name is Mike, right? Let's do that. Let's insert a new record. Let's create a row over here. So ID will be 5, balance will be 1000 and name will be Mike, right? So while this transaction was in progress, transaction T2 inserted a new record with value 5000 and Mike. Now this fifth row is the newly inserted data, right? Now within transaction T1, we are querying again the same query where balance is greater than $150. If you remember, previous query resulted in total 3 row in the set, right? Now this query will result in total 4 row in the set. Basically, other than record ID 3, all are greater than $150, right? So let's remove record with ID 3. Now these two query are same query, right? Select star from account where balance is greater than $150 and within same transaction as well. But we are getting different set of row because while transaction T1 was in progress, transaction T2 inserted a new record with ID 5 which satisfy this where clause. That's why within same transaction we are querying 2 times with same where clause and getting different set of records. This is nothing but phantom read. Next isolation anomaly is nothing but lost updates. What is lost update? A lost update occurs when 2 or more transactions access and modify the same data concurrently, resulting in the loss of one or more updates. This happens because the latter transaction overwrites the changes made by the earlier transaction. Okay, so if you remember at the start of the video, we already have learned about it, right? Where we took example of 2 accounts trying to transfer money to the same account at the same time, right? So we have learned about this at the start of the video where I was talking about why do we even need something like isolation. In that example, I was talking nothing but lost update. So let's quickly look into it, what exactly we have learned at that timestamp. So Alice and Bob is trying to send money to John. There is 2 person, Alice and Bob, and there is a third person called John. Alice is sending $50 to John and Bob is also sending $100 to John. Basically, these two transactions T1 and T2 are happening simultaneously and both are trying to write this data in the John's account, basically over here at row ID 3. So Alice is trying to write $150 and Bob is trying to write $100. So because of this concurrent write, it will result in lost updates. If you want to learn about lost update in detail, let's go to the timestamp where I have taught you about why even isolation is required. Now that we have learned about isolation anomalies, dirty read, non-repeatable read, phantom read, and lost updates, we are ready to learn what exactly is isolation. Now that we have seen what are isolation anomalies, database gives us a way to avoid those isolation anomalies. Isolation anomalies can be a pain where we need consistency, right? So we can define our isolation level based on what anomalies we want to allow our database to prevent and what anomalies we want our database to allow. Allowing or preventing isolation purely depends on application requirement, the level of concurrency, and what kind of performance we are expecting. There are mainly four levels of isolation: read uncommitted, read committed, repeatable read, and serializable. Now, red represents that database allow these anomalies. Green represents database prevents these anomalies. Let's start with read uncommitted. If your transaction is set at read uncommitted, it means it will allow all the anomalies. Basically, we are allowing dirty read, non-repeatable read, phantom read, and lost updates. Similarly, if we are setting our transaction level to be read committed, in that case, we are allowing non-repeatable read, phantom read, and lost update. But we are not allowing dirty read. In that case, all the dirty read will not happen. So if a transaction is not committed, other transaction will not read data which has not been committed. Similarly, there is repeatable read. As the name suggests, we do not allow non-repeatable read, we do not allow dirty read, we do not allow lost updates, but it allows phantom reads. If you do not want to allow any anomalies, the most strict isolation level is nothing but serializable. It do not allow dirty read, non-repeatable read, phantom read, and lost update. Here is a syntax if you want to define your transaction isolation level. All we need to do is set transaction isolation level and then the name of the isolation level. Then we can begin transaction. We write our multiple queries or multiple SQL statements. It can be one or more SQL statements, and then we commit transaction. If anything goes wrong, it will roll back. If it commits, it will be permanently written on the disk. Now the question comes is how to choose isolation level. Choosing isolation level totally depends on application requirement and trade-off between performance and consistency. So if you need high performance, something like if you are building something like a log application or something where a lot of consistency is not required, but you need a lot of performance, right? Very high performance system. Then in that case, we can choose read uncommitted. If you want a balance between performance and consistency, in that case, we can choose read committed. If our requirement is we do not allow non-repeatable read, in that case, we set our isolation level to repeatable read. The most strict consistency is serializable. So if you want to build a system like Book My Show, flight booking system, banking transaction, in that case, we keep our transaction level at serializable because we do not afford to lose or have inconsistent data. So basically, isolation level is nothing but it sets the transaction to operate on which isolation anomalies it wants to allow or prevent. Isolation level controls at what level of consistency query runs. So this is what isolation is. How does database maintains internally the highly concurrent nature of these data updates and prevent being inconsistent, that we will see in upcoming videos. That's all about isolation. Do not forget to subscribe, and if you want to keep getting these updates, please press bell icon. Thanks.